Hey everyone, welcome back to the channel. For those of you who are OGs around these parts, you can see we're back in my original childhood bedroom where I was making the Systems Design 1.0 series, so I'm getting a little nostalgic about it. But yeah, it's been a good week, been off, not working, which is fantastic, and to support all of this extra time that I've had on my hands, we're probably cutting down quite a few extra trees in the Amazon rainforest to support my paper usage. But let's go ahead and get into some videos. Today we're going to be talking about Robinhood. I made a collaboration video on this a while back on a different channel, and I was sufficiently roasted by it from a lot of users in the comments, so let's see if we can do a little bit better this time and try and keep the focus down. Are you a Robinhood user that thinks you can beat the market? Guess what? You probably can't, but if you want to give it a shot, you should probably get your skills up. That's where Brilliant comes in. Brilliant is a platform that allows you to self-study various STEM topics like math, data science, computer science, and machine learning. As I age, I've come to accept that my chances of becoming an alpha male gym tank are pretty low, since I'm too soft to inject steroids into my body. Instead, I'm going to go the alternate route of attempting to attract my wife with monetary success, and perhaps, if I stop looking at blind, my intelligence too. I've found that, in particular, Brilliant's new LLM course has been a major enabler for me to learn about key topics in modern artificial intelligence. It allows you to get hands-on experience with real language models. I can supplement that with Brilliant's great courses on statistics and probability to become a self-taught quant. Now, instead of trading GameStop options expiring today, Citadel can get my flow in commodities and crypto. To try everything that Brilliant has to offer for free for 30 days, check out brilliant.org/JordanHasNoLife or click the link in the description. You'll also get 20% off of an annual subscription to Premium. Okay, so as I mentioned, I've kind of made this video before, albeit not on this channel, so I wanted to take the opportunity to go ahead and remake it using my typical format and see if it could help people out. The gist is, I think that one thing people were particularly hostile towards last time was I went into probably the finance and the stock-specific and option-specific aspects of things a little bit more than was necessary. And in this episode, I'm still going to touch upon those because I do think it's essential to kind of understand some of the dynamics there to actually build out Robinhood and understand the actual complexity of the problem. But I'm not going to go as deep into it because, to tell you the truth, there are many different ways of calculating the price of a stock and option. It's not really worth discussing them for too long. Probably 90% of the time, a tech company is going to give you this interview, and they're not really going to care so long as you kind of get the essence of the problem. So let's go ahead and get into it. As you can see, we've got Robinhood over here on the screen. This would be an example of my portfolio, which obviously is quite going to be down since I've been listening to Wall Street Bets a little bit too much. So I've got GameStop, Dogecoin, AMC, some GameStop call expiring, let's see, in 2 days from now. And then we've also got Corinna Kopf coin. That's a new one. And pretty much all of those are doing quite poorly. So you can see I've got my total portfolio value. We can see, on the front end at least, we've got a chart of some historical prices as well. But mainly what I care about for this problem, because I think that's going to be the more interesting component of all of this, is number one, that we should be able to buy and sell financial products. So Robinhood is a brokerage, right? You're not actually buying and selling things through them or with other Robinhood users, but they're basically routing your orders to a stock exchange or an option exchange or something along those lines. So we're not going to go too much into actually building the exchange itself. That's worthy of a entirely separate video, which we'll do eventually, but for right now we're just going to focus on Robinhood. And then additionally, we want to be able to see the real-time value of our assets, and these are changing constantly. So we're going to talk about that a little bit more, as well as total portfolio value. So total portfolio value can be derived really simply from knowing the value of every single asset. On the front end, you can just go ahead and take every asset that you have, multiply it by the quantity that you own of it, and then that's your total portfolio value. So that part's pretty simple, but getting the actual price of every asset is not so simple. Number three is that we want to minimize the number of servers that we have listening to the exchange. So this is one of those finance-specific pieces, right? Because you might think, oh, well, why not just have 10,000 servers listening to the exchange to get information for every user and then dissipate it to a particular user? Servers are pretty inexpensive. We can just have a cheap EC2 instance. Well, for starters, there's a lot of load on these servers that have to listen to the exchange because exchanges publish tons of information. And number two, it actually costs money for us to listen to the exchange. So that's a pretty fundamentally important part of getting some exchange data, as you don't want to actually just have tons of servers that you've registered to listen to it. Okay, and then three, just for the sake of a brief capacity estimate, I'm going to estimate around 100 million users, 100 million daily active users. Someone got mad at me in the comment section of the last time for not explicitly saying that. And we'll estimate that on average each user has maybe 100 different instruments in their portfolio, where an instrument could be, let's say, a stock or an option. So the first thing that I want to do is lay out a couple of initial thoughts for this problem, because I think this particular framework is going to allow us to kind of, start from a given and then derive the remainder of our solution from there. So number one is that most people who use Robinhood are using it from their cell phone. It's a phone app, and so I actually don't even know if they support a computer app. I think they do, but it's pretty poor anyway. So because we're connecting via a mobile device the majority of the time, we want to limit the amount of load that we're actually putting on that device. And so typically what that means is we want to limit the number of active connections. And so if you're thinking like, oh, maybe I have 100 different devices, or rather 100 different instruments in my portfolio, now I need one active WebSocket or service and event or something like that per instrument to get the prices, maybe that's not so feasible, because it's going to put a lot of load on that device. We're going to use a lot of data, we're going to use a lot of battery, and so it would really ruin the user experience. So you want to try and keep it to a single active connection per client. And then additionally, if we do have a client that's connected from multiple devices, because you can have multiple phones, you can have a phone and a laptop, ideally we want those to be connected to that same server, right? Because they're going to be requesting all the same information. There's no reason that we want to basically be duplicating all of that work to a couple of different servers. So ideally what that means is just that we're going to perform some sort of consistent hashing via load balancer when we connect via our client device, and then that's going to point us to the right server that has all the information that we care about. Okay, and then finally, so let's imagine that the client is connecting to some sort of server to get all of this pricing information. We're going to call these the user servers, or at least that's what I'm going to dub them for the sake of this video. We don't want those listening to the exchange directly, because as I mentioned, if you have tons of user servers, because we have tons of users, and each one of those is listening to an exchange or perhaps even multiple exchanges, then it's going to cost us a lot of money. We have to pay for a bunch of subscriptions, and that would be bad. So if we're Robinhood, we probably don't want to do that. That's going to be a lot of duplicate work, so we're going to try and avoid this. So the first thing that I'm going to start by talking about is actually placing orders. So basically the gist of this is that, again, Robinhood is a brokerage. They're not an exchange. They're basically forwarding your orders to the exchange. Now, in reality, they do something called payment for order flow, which I don't want to get into too much, but the gist is that, Robinhood will say, ooh, I want someone who wants to buy a share of Google stock. Hey, Citadel, can you go decide which exchange this is going to for me? Citadel, pays them a couple pennies for the right to decide which exchange it goes to, and then Citadel, makes a market on that exchange, hopes to trade against the customer, and makes a little bit of money. Just is, topic for another day, and frankly, it's more of a legal regulatory topic than anything. But yeah. So the gist is we're basically sending our order to some sort of gateway, and then it gets handled for us. So let's see. We're going to basically place an order in our gateway, and then once we place an order, it actually might take some time for it to be filled, right? There's no guarantee that me saying, hey, I want to buy a share of Google is actually going to find a counterparty to sell me a share of Google. It might happen, it might not, and basically until I explicitly get that order filled or I cancel it, that order can basically sit on the exchange the entire time doing absolutely nothing. So, I'm just going to use the term pending for that. And then, of course, if you do have a pending order that has yet to be filled, you can cancel it. And so for canceling orders, now we have some sort of race condition, right? Where at least internally in Robinhood, we have a concept of which pending orders a user has open, but we need to be sure that when they click the cancel button, we actually cancel them in the exchange first before reporting to the user that their order was canceled. Because if we don't, what could basically happen is, we tell them the order was canceled, and then the order could actually be filled right before we go to the exchange and cancel it. So it's not a bad race condition. The gist is basically first you want to go to the exchange, cancel the order, and then once the exchange says, yes, you've successfully canceled this, then you can report back to the user that it was canceled successfully. Cool, so let's go through the order placing diagram. So I'm just going to quickly outline this to make it clear for everyone. So imagine we've got this Robinhood client over here, and he wants to place an order to buy a share of a stock. The first thing that he's going to do is probably, hit some Robinhood server, and that's going to put it in some sort of pending orders table. Right, so we've got our orders table over here. I'm using MySQL because I would prefer to just have a single leader, keep everything simple. I don't really want to deal with any write conflicts. I don't want to deal with stale reads here. I just want to read from the leader, write to the leader. I think we can shard this out amongst user IDs to make sure that we have sufficient write throughput. But the gist is the orders table is basically going to contain my user ID, what stock or option it is that I want to order, the quantity of it, the status, which originally would be something like pending, and then some sort of order ID itself, which we can auto-generate, doesn't really matter. The next thing we're going to do once we have this pending order in the database is we can go to our order gateway. This is where we're going to be doing all that payment for order flow stuff, which again, in and of itself is basically a bidding process, but I'm going to abstract that all away for now. Just as from here, we then go to the exchange, we place some order. The exchange is going to probably give us a separate ID that they made up on their end, some sort of exchange ID. And then now the problem is, if that order were to be filled and, we hear from the exchange that the order was filled, we need to be able to basically map it back to a Robinhood order ID because the exchange order ID is not going to be the same as the Robinhood order ID. So at this point, once we get that exchange order ID, we probably want to go to some other database table, which I'm going to call like the order mapping table. Again, just keep it simple, put it in MySQL. We can just shard it on the hash of the exchange order ID, so we can make sure to effectively just round robin all of these requests and make sure load is distributed evenly across the databases. And what that table is going to have is basically the exchange order ID that the exchange just gave us, the user ID, so that we can quickly figure out which partition we need to go to in this orders table, and then the order ID itself. And so then we also have a bunch of listeners that are basically trying to listen from the exchange, seeing all the trades that were done, and then if they recognize a particular exchange ID based on what's present in this table, they can go ahead and update this orders table over here to say that an order was not just pending, but now that it's filled. Okay, similarly, we might not fill every order, right? We may just choose to cancel some of them before they're filled. So in this case, what we can do is, like I mentioned, you want to go to the exchange first, actually cancel the order and confirm that it's been canceled. So step 1 is that we go over here. Step 2 is that we take our Robinhood order ID and figure out the exchange order ID for it by going into this order mappings table. We then go to the exchange, cancel it, and then once we hear about that successfully, we can go to our order table and basically put in the new status as canceled. So hopefully that all makes sense for everyone. Okay, now we're going to discuss the actual pricing because this, at least in my opinion, is kind of the meat of the video. I think it's hardest to actually figure out the stock prices and distribute them accordingly. So let's go ahead and discuss that. So this is going to be, like a little bit of finance context that you do need to solve this problem. Otherwise, I think it would be a little bit too basic and not that interesting in the first place. So when you have a stock or an option in real life, there's not really an inherent price for it, right? There's just what people are willing to pay. So let's imagine we're talking about one share of GameStop, right? Let's say I'm willing to pay $3. I'm willing to buy it for $3, and TechLead is willing to sell it to me for $5. So basically, I think this thing is worth less than TechLead does. We're not going to trade with one another because we can't decide on a price for it. Trades themselves will actually happen when basically I'm willing to buy for more than someone else is willing to sell. So let's say I'd actually wanted to buy this thing for $6. TechLead wanted to sell for $5. We would actually exchange that share and we would trade at some price. Now, depending on the exchange, it depends what price we would use. It's probably going to be between $6 and $5, but hard to say exactly which one. So there's going to be some sort of trade price, right? So the question is, how is it that we actually determine the price of the asset itself? Are we going to use the trade price? Are we going to use some combination of the active bids and the asks, where the bids are just how much people are willing to buy for, the asks are how much people are willing to sell for? Well, it kind of depends, right? I mentioned those over here. We have the last trade price. We have the highest buy price and the lowest sell price, and we can average those. But this actually gets a little bit more complex, right? Because in fact, not only is this stock offered on just one exchange, it's actually offered probably on multiple exchanges, especially if we're talking about options. So we can have people who are willing to buy the option and willing to sell the option on multiple different exchanges. They might not even be able to trade with one another because they're on different exchanges, but they may still find the stock or the option to be worth some amount. And as a result of that, that does give us some pricing information about it. As you can see, I've got a lovely ambulance in my background, which is one of the perks of living in New York City, is that you hear this stuff all the time. Additionally, if we really wanted to get complicated with it, instead of just doing an average of, let's say, the best bid across exchanges and the best offer across exchanges, I could do something like a volume weighted average, right? Because I might be willing to say, buy at $3 for 100 of the share, and then someone else might be willing to sell at $5 for 200 of the share, meaning they want to sell a quantity of 200, and then you could use some sort of weighted average between the two of those to basically, push it towards the sell price because they're willing to trade at a higher quantity. So there are plenty of different ways to actually compute the price itself. I think I probably spent too much time in that original Robinhood video discussing how we would actually do those from like a data structures and algorithms perspective. And to tell you the truth, I think that's a good exercise to do on your own, right? Decide on a price that you want to use, figure out what type of data structures you would actually want to use to get there and do so efficiently. But right now the main thing is we have information coming from many exchanges. We need to aggregate it in one place, decide on a price. Cool. So what do we actually have so far that we have discussed? Well, basically we've got myself over here. I'm the client. I'm going to be reading my positions from some sort of database table. And as you can see here, I basically said, okay, well, we have an orders table. We can create this positions table using derived data, change data capture, have a Kafka consumer, basically update the total position in the full positions table. Easy enough. Another thing after reading our positions is then, we've logged on, we've read our positions. Now we want to go to some sort of load balancer because we want, based on our user ID, to connect to one user server, which is going to be providing us with the prices for all the things that we care about. This is very important because, as we mentioned, we only want to maintain one active connection per client device. And we can do so via WebSocket so that in real time we can basically update that user server with which symbols we care about, and the user server can update us with the prices of those symbols. So we do want bidirectional communication here. We don't want to be resending headers all the time, like via a long poll or an HTTP request, and we do probably want this stuff in real time. So it would be great to be able to use something like a WebSocket. So the gist is, like I mentioned, we would say, okay, I'm interested in the prices for GME, I'm interested in the prices for Dogecoin. Let me go ahead and get them. And then the user server, now it says, okay, well, now I have to fetch the prices for GME and Dogecoin. We've got all of the exchanges over here, which can be sharded in a variety of different ways because, different exchanges have different network topologies themselves. So how are we going to go ahead and basically dissipate the prices from the exchanges over to our user server? And that's what we're going to spend the rest of this video talking about. So the first thing that I want to talk about is the concept of this exchange layer, right? So we've got all of these exchange servers over here. They basically publish out data via UDP. And again, it's expensive to subscribe to this data. So we want to keep this exchange layer, which is directly listening to all of the data regarding the trades that were made on these stocks and options and the actual bids and asks available for these stocks and options. And we want to make this layer as small as possible. So, like I mentioned, that data gets published over UDP multicast. Again, not too important, kind of implementation specific. And typically they'll do some amount of sharding, but again, depends on the exchange. Certain exchanges have to shard, certain others don't. And so, basically, again, we're not going to be talking about the architecture of the exchange in this video, but the gist is that we want to keep that layer as small as possible. We don't want one exchange-facing server per user, right? If we had one of these user servers for every single user and they were listening to basically all the exchange data to get the prices, that would be very bad because it would be very expensive. Cool. So again, ideally what we want is to basically just have, for each of these exchange guys over here, we want one server listening to each shard, or perhaps one server listening to multiple shards, but the gist is we don't want basically 10 servers listening to the same shard over here and all getting that data. Now we may end up having two by virtue of attempting to achieve fault tolerance, and we can do this basically via an active-active or some sort of active-passive configuration. So active-active, they would basically both be listening to the exchange, and they would both basically be publishing redundant information to the remainder of our system. And in an active-passive configuration, they would both be listening to the exchange, but only one is actually publishing data. So the advantage of the active-active configuration would be that price updates would be published twice. However, there wouldn't be any downtime if one of them went down, right? Because the other one would just still be publishing. That being said, we do need a little bit of extra logic to handle the duplicate price updates. How could we do that? Well, presumably because all these exchanges are pretty much ordered within a partition, you could use the sequence number of every single trade or something like that to basically ignore updates from the second device. Or you could just say, okay, well, I know this incoming price update just came from device number 2. I only care about updates from device number 1, so I'm not going to listen to this for the moment. Active-passive, basically we only publish one time. However, If the active server goes down, we basically need Zookeeper to register that. We need it to update its config. We need everyone else to understand that. And Zookeeper, by virtue of being something that employs distributed consensus, can be a little bit slower than the typical database. And so maybe we'll have a slight downtime of like a little under a second or something if a node fails. When I say a little under a second, I have no clue. It could be a few milliseconds. We would have to check it in practice. But the gist is, in theory at least, I would think you would have a little bit more downtime running an active-passive configuration, but the logic would be a little bit easier to deal with. Okay, so we have all of these publisher nodes, right, listening to the various shards of the exchange, and actually the multiple exchanges, right, because at least in the above video, we've got two exchanges, right, A and B, and this one, A, has multiple different shards, and so we want to ideally keep it to basically one or two exchange publishing servers that are listening to each shard. But from there, ooh, great voice crack there. From there, we basically want to be able to aggregate prices, right? Because of the fact that there are multiple different exchanges that are publishing prices for a given asset, right? Let's say we were talking about a GME option, so a GameStop option, that can be published on multiple different exchanges. And as a result of that, we basically need to take all of the information from each exchange about that particular product and aggregate it. And so what we can do is use another server in order to do that. And that's what I'm going to dub the pricing layer. So the pricing layer is going to do two main things. The first is that it's going to take in all the information from the exchange publishing layer, and it's going to aggregate it for a given ticker. So this could be like a GameStop option, it could be a Google stock, anything along those lines. And number two is that it is going to be responsible for acting as the middleman for delivering prices to the user layer. Now we're going to talk about how this server in particular might have a lot of load on it by virtue of the design I've chosen here and how to mitigate that. But for now, let's keep things simple. So basically, imagine we have this pricing server for GameStop. GameStop stocks trade on both Exchange A and Exchange B. And so what we have, this is all not us, right? This is all just exchange architecture. Robinhood starts over here. These are our listeners. And so this exchange publishing layer, we're going to have one node for Exchange Server A, one node for Exchange Server B, and they're basically both going to be publishing those trade prices over to our pricing server, which can then aggregate them and say, ooh, you know what, the new price is actually 1 cent higher than it was before. Let me go ahead and notify all of our user servers, which are connected to me via a WebSocket. So hopefully that makes sense for now. And of course, if we're not just doing this off of the last trade price or the last done price, as it's actually called, and we're doing this off of some sort of stateful calculation, maybe a moving average, maybe we're looking at the active bids and asks, we're going to have to keep some state in here. And so, in order to make sure that it's fault tolerant, perhaps we would also want to do some amount of like state machine replication, where we have a backup over here, and all the publishers that are publishing to this guy also publish to this guy, and then we've also got Zookeeper over here to perform failover in the event that our primary goes down. Because every piece of our backend here we do want to be fault tolerant, and the way that we tend to do that, at least when all this stuff is being kept in memory, is via state machine replication with a failover. Cool. So let's go ahead and shard it on the hash of the tickers. That is one thing that I didn't mention. This guy is just going to be responsible for GameStop, maybe a couple of other tickers, but we do ideally want even load on all of these pricing servers. That being said, in the case of some tickers, generally they're just going to be too expensive, right? If you're familiar with the American stock system, there are certain things that just tons of people trade. There's one thing called the SPY, which is a very popular index that pretty much everyone trades. And it would be hard for me to believe, for example, that for that ticker in particular, due to the just sheer amount of volume of bids and asks and trades on it, that one particular server, even if it's super, super beefy, could handle it. So in this case, we may actually have to do some extra work. So we can be overloaded on the pricing server in two senses. For starters, this guy over here can publish too much information to it. And then secondary, we can have tons of different user servers that are interested in getting that information via WebSocket on our pricing server. And as a result, we can have problematic things going on here where we basically have to push that data to too many different places. We have too many active connections, and then we're in trouble. So what can we actually do to mitigate the load? Well, number one, in the case of the exchange publishers, perhaps what we could do is actually basically just throttle how often we publish, right? So I mentioned this in particular for the last trade case, because if there are tons of trades, maybe we only publish 1 out of every 10 of them, because probably it's going to be the case that all of those trades are happening at the same price, and then maybe every 10 or so, maybe we'll see a little bit of fluctuation. Perhaps we could also keep a little bit of state in those exchange publishers and publish an average price over them, right? So I see the last 10 trade prices, I calculate the average, and I only publish 1/10 as many messages to my pricing server. So that's an option if you want to be, pricing all of these things off the last price that they traded at. However, another option that we have is to, again, like I mentioned, price them off of like the open bids and asks in the order book, where the bids are just how much everyone is willing to pay, and the asks are how much everyone is willing to sell for. If we wanted to do that, well, what we could do is each publisher for a given exchange could basically, build up some local state of those bids and asks, calculate one price every couple of seconds, or not every couple of seconds, but maybe every half second or something like that, and then publish that out to our pricing layer, and then the pricing layer would again, take the average or aggregate them somehow over all the different exchanges. Instead of doing any of that, we could send a full snapshot of that order book. Either way, I think this is all implementation details. As long as you make note of the fact that there are many different ways of computing this pricing with your interviewer and ask them how they want the pricing computed, then I think you can go a lot deeper into this. Cool. And then the second aspect of this is, well, if a lot of users are interested in the prices of one particular asset and we only have one pricing server for that asset, how can we actually disseminate all of these prices for that one asset to all of our users that care about it? So again, the problem we can run into there is we have too many active connections, and that would be bad. So at least in this case, what I would recommend doing, or I guess recommend is a strong word, but what I think about doing is basically, resharding, right? So you can basically take a bunch of other servers for that particular super popular asset, put them up as effectively just pseudo pricing servers, and then push all of our pricing information from our one pricing server to those pricing servers. And then ideally, we're not pushing it to too many places, and each one of those pricing servers can handle a bunch of WebSocket connections. So what does that look like in practice? Let's imagine it's 2020. Everyone cares about GameStop again. So we've got our GameStop pricing server, which is super overloaded. What we do instead is we go ahead and set up all of these auxiliary pricing caches. We publish to, let's say, just 2 of them for now, but maybe, in reality, we'd want to publish to 10 of them. And then when a user is interested in the GameStop price, rather than connecting over here, we use some sort of round-robin load balancing to randomly attach us either to here or to here. And ideally, all of these caches should have relatively even load on them. Cool. So let's go ahead and bring everything together as we have spoken about it this entire time. So like I mentioned, the first aspect of this whole thing over here is that a client can, of course, place some actual orders. And the way they would do that is by hitting our order service. The order service needs to basically have some sort of orders database so that a client actually knows, what pending, what filled, what canceled orders they've made in the past. I think using MySQL here is going to keep it simple. I don't think the write nor the read throughput on this table is going to be super high, because I would expect that we're probably just going to read it once when we open up the app, and we're probably just going to write it whenever we place an order. And it's not like people are just like spamming orders every 2 seconds. People aren't really algorithmically trading on Robinhood. And if they are, they have a problem. Again, we can shard that on user ID, the reason being that if I'm a user and I want to read all of my orders, it would be great if they were all on one single partition. And then just index those on order ID so it's easy to find a particular order ID for a given user. Next, we also have our order mapping database. The reason that we need this is because when we actually go to the exchange and place an order, it's going to give us some ID, but it's probably not going to be corresponding to the one that we have in Robinhood. And so we need a way of basically mapping our exchange ID to the order ID in Robinhood. And so the way that we can easily do that is just by sharding on the exchange order ID. So, you go to some load balancer, say, hey, I have this ID right here. What partition does it live on? Then you go to the right instance of your order mapping database, or your order mapping database partition, fetch your Robinhood order ID, and handle it accordingly. The last piece of the puzzle is going to be this exchange order gateway, which basically is just going to act as a proxy for doing all your payment for order flow stuff. But the eventual result of this is that that order is going to be placed on some exchange. We don't know which. It doesn't really matter. It's abstracted away from us. Not too important. So piece number two of this puzzle is, if I'm a client and I have 10 things in my portfolio, I need to actually be able to see the prices of those. ideally in relatively real time. It may be the case that, if Robinhood decides, hey, people don't actually need to know the price of all their assets in real time, but maybe every 1 second we can update them. Maybe this WebSocket over here that I'm connecting to the user server could become something like a poll or a long poll, or we poll on an interval. But for now, I'm going to act like we do want these updates in relatively real time. So the way that we actually go ahead and connect to a user server, like I mentioned, is we want to do it based off of our user ID. So that if we have multiple different devices for a given client, they're all connected to the same guy. So the way that we can do that is just by putting some load balancer in the middle of things. We hit the load balancer, it tells us which user server we should be connecting to, and then we establish a WebSocket connection there to basically enable real-time bidirectional communication. Everything is, of course, going to be listening to Zookeeper, including our load balancer, including our pricing servers, including all of our exchange publishers as well, because we need our active-passive configuration for all of these guys. And so from there, basically our user server now has to gather all of the pricing that it needs. So the user server can say, hey, for user 1 or user Jordan, he's interested in GME and AMC. And then Zookeeper will say, oh, okay, well, if you're interested in those things, you should probably establish a WebSocket to this guy over here and this guy over here. At which point, what's now going to happen is that these guys are the pricing servers, and they basically need to aggregate a single price for all of those tickers. The way that they do that is by having a bunch of publishers who listen to exchange data, like this guy over here, publish all of the data to them, and then they can statefully aggregate it in memory per symbol that they care about. And so the way that they're going to do that is, maybe we have a bunch of different publishers. The publishers themselves are also listening to Zookeeper to know where they should be forwarding all the relevant information to. And then they can forward it to the proper pricing servers, which again are sharded on the actual symbol of the financial asset. So, you listen to Zookeeper config, it says, oh, GME is up here, AMC is down here. So maybe this guy, publisher 3, is publishing all AMC prices, and publisher 1 and 2 are responsible for GME prices. Again, like I mentioned, for particularly busy assets, it's possible that publisher 1 and publisher 2 may have to do some sort of throttling or extra logic on their end to actually, come up with a slightly aggregated price for that particular exchange or whatever they're listening to, and then there would be a little bit more aggregation on the pricing server itself. Well, guys, hopefully this video made a little bit of sense. Hoping you're enjoying it, and thanks for all the great feedback on all the Substack notes that I put up. I'm going to try and get all of the actual systems design problems notes up within the next couple of days as well. So hopefully those are useful for everyone. Anyways, enjoy your week, and I will see you in the next one.